Oh, no,
Okay. Just wanted to encourage people who are interested in learning more about this. I have a course at alldeep.ai for causal modeling in AI, which combines Bayesian hierarchical modeling, probabilistic programming like you have with PyMC, and some intervention modeling. We're actually working on some material for intervention modeling with dynamic systems like the SIR model, which is actually a tricky problem. And so right now the courses are all fully booked, but you can enroll in a mini course and then we'll let you know when the causal modeling course opens up again. So I just wanted to put that on your radar. Cool. I want to take some questions. Let's see here. We had some great questions. Another question was about loss functions, right? So if you wanted to say, for example, I don't know, assign some kind of price to human life, like in the number of deaths or something like that, is there a way that you can say connect interventions to not just actual absolute outcome predictions, but put some kind of cost function on it and get a posterior expectation of loss, so that you could say, let's find the intervention that minimizes this loss?
Yes.
Is that something you've thought about or you've experimented with?
Yeah, I love that question. That's like the perfect setup for something that I forgot to say. So this is something that I became really excited about recently, called Bayesian decision making, which has been around for ages, but for me it was a rediscovery. And that allows you to say, okay, I have a model and it's making all these different predictions. Now I would define a loss function and say, for example, let's say we want to know, we have a model that predicts, well, the number of cases that are going to have to go to the ICU. And then I could say, well, what is the cost of ramping that up, or how much extra buffer should I build into the system, right? And at what cost? So you can, with the loss function, define what is the cost of going over capacity, or how much margin of error you want to introduce. And then you can solve that optimization problem using Bayesian decision making. And so this is a blog post that I wrote on this that goes through that logic. And I think that is really a very critical component in general of Bayesian statistics, where you don't just want the output to be posteriors, right, which no one understands and people who are not statisticians won't care about. You want the output to be decisions. And that is what you can do with this. And yeah, loss function is the way to go. And then you optimize over that. And critically, you're not only optimizing for the best case, but you're optimizing for the whole distribution of possible outcomes.
So a couple questions about overfitting and accuracy. So you have been looking largely at goodness of fit. And of course, if you're doing Bayesian modeling, there's some kind of built-in Bayesian outcomes razor there. So I might address overfitting a little bit. Aside from looking at fit to the data in terms of likelihood and posterior, have you looked at anything like predictive accuracy to validate the model?
So in this case, I haven't done that, but it's a good exercise to do and sort of try and see how well, if you have some holdout, for example, how well does it predict that? You retain some data like you would do in machine learning. That's a good thing to do in general. But there's also other kinds of more Bayesian approaches, like you can estimate a leave one out cross-validation method and check the accuracy that way, or there's different information criteria you can use to assess how good your model fits the data and how many patterns the model can generate. So, but in general, I would say the risk of overfitting is way lower in Bayesian statistics just because our models are so much more constrained. So in machine learning, the algorithms are designed to be very, very flexible, right? And fit any type of pattern or functional shape that you can imagine. And because of that, you can easily fit to noise. But if you have a parametric model that has, say, only 2 parameters, right? So that is going to be way more robust to overfitting, just because, yeah, the model is way simpler and has fewer knobs to tweak to overfit on.
So you mentioned some Bayesian scores for like are asymptotically equivalent to cross-validation. Do you have abstractions for those implemented inside PyMC3?
Yes. So there is, for example, yeah, leave one out, and all these, yeah. So there's a notebook on model comparison that you can check out that goes through all these different measures.
So a couple of questions about the SIR models. Let me see if I can answer these questions and you tell me if I'm wrong. So that generally speaking, the modeling approach is the same. It's just that you need an ODE solver, but the hierarchical modeling is focused on the parameters of these models. Okay. And can you use these models to estimate R naught, the expected amount of infected people that an infected person infects?
Yes. In fact, in the SRR model, that directly falls out. So that is one of the parameters. One other thing, on Quantopian, we also will post next week a challenge where you can win a cash prize to come up with interesting analyses around how COVID-19 affects the economy and the financial system and the financial markets. So if you are interested in economics or finance, definitely check that out.
So you, as you know, so you're VP of Data Science at Quantopian, which is a quantitative finance company. How has your modeling effort here maybe changed or affect your outlook on, well, on the pandemic and, of course, the second order consequences to the economy and to society in general?
Yeah, so that is interesting. So I definitely was also so I ignored this for a long time. And then once I started looking into it and also actually running these models myself, and that was, I don't know, a month ago, it became immediately clear to me how serious the situation was really going to be. And I was quite frustrated with the slow reactivity I saw in many Western countries of implementing these necessary changes like school closures. For me, it was clear that that had to happen, and if those things if those things have to happen, then it's better to make them early, right? While it's still in the beginning of that slope. So it was sort of difficult to wrap my head around that many people just kept looking at the numbers and, well, they're still low, but that doesn't really matter. The question is, where are they going? And with these models and these forecasts, even if they're not super accurate, definitely, I think, demonstrate the severity of this, and just seeing really exponential growth, because we can intuitively reason about that, is just very striking to extrapolate with these, even with these simple models. And I guess the other thing is also that I'm going to pay way more attention to Nassim Taleb, who, like, very early on tweeted about this, like, oh yeah, it's very costly to be wrong on these and we should act very early. And I actually tweeted that I disagreed, that, like, well, we should be more chill, but he was completely correct. I mean, this was would have been the right course of action, and these tail risks are not to be underestimated and be taken very seriously.
I'll end on that. Thanks, everybody, for joining today. I apologize for some of the technical issues. Obviously, the internet is a bit overstressed these days. I'm going to try and do some more of these, so please stay tuned, and I'd love your feedback. Reach out to us, either of us, on Twitter, and again, make sure that you check out this Quantopian's challenge next week.
Thanks, Robert, and thanks everyone for tuning in.
Thank you.